Determine whether the curve, whose x-coordinate is given by e to the t squared, and whose y-coordinate is given by 4 minus t, intersects itself. Alright, what does it mean for a curve to intersect itself? So it sort of goes back and visits a point that it's already done before. Okay. And so what we'll need are two different values of our parameter, in this case t, that give us the same point. That's the idea behind the self-intersection. The way we handle this is we set up a system of equations. So both values of x need to be the same, even though the parameter values are different. And both values of y need to be the same, even though the parameters are different. Okay. So the way we set this up is we introduce a brand new parameter s, okay, but we use it in place of the t. Okay, so we get the normal t expressions for x and y. Okay, and then we use those same expressions, but now with this separate parameter s. Because if we kept t in there, you'd have, well, the x value needs to be equal to the x value, but it's the same t. It'd get very confusing. So we introduce a new parameter s, and all we ask is, can we solve this with s not equal to t? Okay, and there might be other constraints we need to satisfy, but we weren't given any in the question. So we just need two different values of our parameter, s and t. Okay, can we find s and t that satisfy both of these equations at the same time? Well, if we take a look at the second one here, 4 minus t is equal to 4 minus s, get rid of the 4's, divide both sides by -1, we see that the second equation here can only be satisfied if s and t are the same. So you'd have the same value of the parameter, and that's why you get the same point. Well, that's not what we want. Okay? S and t have to be different, and so this sort of results in a contradiction. You can't have s and t be the same if we're asking for different values of the parameter that give the same point. So the answer is no. We don't even need to look at the x equation. Doesn't matter. Right? You can't satisfy the second one without having the same value for s and t, which is what we're trying to avoid. So no, the curve doesn't self-intersect.